Hi guys, this is a tutorial on electron configuration. You will need your periodic table and you need to make sure you have it in your sheet protector so that you can try writing on it with a dry erase marker. That will help a lot as we go through this. So remember that we're talking about the quantum mechanical model of the atom proposed by Schrodinger, which talks about how the electron cloud is organized. And it tells us that the electron cloud is broken down into larger divisions that we call energy levels, and that the energy levels are broken down into smaller sublevels, and that these sublevels are broken down into smaller orbitals. Okay, remember that the orbitals are essentially the three-dimensional region that's the home of the electron. It's where the electrons are actually roaming around. They're not considered to be in orbits like in Bohr's planetary model. They can move anywhere within an orbital that they want, but they're not necessarily orbiting the nucleus like planets around the sun. Our sublevels, again, which are made up by orbitals, are referred to as S, P, D, and F. They are lowercase letters, and they do stand for things. Sharp for S, P, principal, D, diffuse, F, fundamental. But they are universally known as just S, P, D, and F. Those are the sublevels. The energy levels are numbered 1 through 7, and that's because they correspond to the period on the periodic table. Remember, periods are the horizontal rows that go left to right, and the variable for energy level is N. The lowercase n stands for energy level. All right, so it's important to know those things. So if we have an S sublevel, remember what makes up a sublevel is an orbital. So if we have our sublevels organized by name, S, P, D, and F, okay, remember again, those are the sublevels, which are made up by orbitals. The S sublevel is made of 1 orbital. The P sublevel is made of 3 orbitals, 3 places, 3 D regions where an electron can roam around. The D sublevel is made of 5 orbitals, 5 3D regions where an electron can roam. The F sublevel is made of 7 orbitals, 7 3D regions where an electron is found. Each orbital holds 2 electrons. So we're able to calculate the maximum number of electrons that can be in any sublevel because each orbital only holds 2 electrons. So 1 orbital times 2 electrons means that we can have 2 electrons in the S sublevel. 3 orbitals rather, with 2 electrons in each gives us 6 electrons max in the P sublevel. 5 orbitals making up the D sublevel, 2 in each one, gives us a maximum of 10 electrons in the D sublevel. And in F, with 7 orbitals, 2 electrons in each one, we can have a maximum of 14 electrons in the F sublevel. So it's important to know that because these sublevels and the numbers of electrons they hold correspond to our groups on the periodic table. The groups are the up and down columns. So you can see on the periodic table here that group 1A and 2A make up the S sublevel. You can see over here that excluding helium, these 6 columns, 3A, 4A, 5A, 6A, 7A, 8A, these 6 columns make up the P sublevel because P can hold 6 electrons. And these columns here, known as group B elements, because they don't have an A after their number, notice it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns, 10 groups, and D holds 10, so this is our D block, our D sublevel. A block and a sublevel are the same thing. When we come down to these bottom 2 rows, this is our F sublevel. Notice if we count the elements in the groups, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And again, that's because the F sublevel holds 14 electrons. So whereas our periods, our horizontal rows, are the energy levels, this is period 1 going this way, period 2, period 3, period 4, period 5, okay, period 6, energy level 6, period 7, energy level 7. Those periods are the energy levels. Okay, these 2 at the bottom are not 8 and 9. This is really period 6 This is really period 7. Okay, that's because period 6 really belongs up here in main 6. This period 7 down here really belongs up in main period 7. Okay, so the periods that go across horizontally this way are our energy levels, and then the columns correspond to our sublevels. These 2 here are S. These 6, excluding helium, are P. Notice helium here is S. These 10 sunken down between S and P are D. And then these 14 down here, that's the F sublevel. Something important to note. When you enter the D sublevel, the energy level, N, drops by 1. Okay, if we notice, this is period 4, yet when we enter the D sublevel, it's now 3. This is period 5, and we enter the D sublevel, it's now 4. The energy level is dropping by 1, from 4 to 3, from 5 to 4. This is period 6, energy level 6. We entered D, it went to 5, dropped by 1. This is period 7, it entered D, it dropped by 1 to 6. So it's important to remember when you enter the D sublevel, the energy level N drops by 1. When we enter down here the F sublevel, okay, what do you notice? It went from 6 to 4. 6 to 4 means it dropped by 2. So 6 to 4 means the energy level N dropped by 2. Okay, if we look at 7, it changed to 5. So 7 minus 2 is 5. Again, the energy level dropped by 2. So it's important to note when you enter the F sublevel, the energy level drops by 2. And when we enter up here the D sublevel, it only drops by 1. Okay, so why does it do that? So let's take a look at our atomic number. Okay, so if we mark where the D sublevel begins, let's look at our periodic table. The D sublevel begins with these elements here. The F sublevel begins with these 2. And if we follow our atomic number, we notice you go from 56 and then it jumps to 71. You can't go from 56 to 71. The atomic number is prompting you to go from 56 down here to 57. So notice if you're writing an electron configuration, you've got to go here from period 6, energy level 6, through these 2 elements, which are S sublevel. And once you've gone through these 2 and 6s, the atomic number 56 is prompting you to drop down into this F sublevel at 57. This is period 6, and since we have dropped to the F sublevel, the energy level changes by 2. So we've gone from 6s to 4f. The atomic number is prompting us to do that. If we notice here in period 7, francium and radium, this is 7s. The atomic number 88 prompts us to find 89, which is down here, again in the F sublevel. So we were in period 7 here, but since we've entered F and the energy level drops by 2, now we've moved from 7s to 5f as soon as we hit actinium at atomic number 89. So the atomic number is prompting you which energy levels to go through. Okay, so let's write an electron configuration for a simple element to begin with, beryllium. Okay, find beryllium on your periodic table. Let's circle it. We see its atomic number 4, so it has 4 protons, so therefore it has 4 electrons if it's a neutral atom, which they all start out as. So we have to go through and cross out every element in chronological order on our way to beryllium to write its electron configuration. So we have to start right up here with atomic number 1, hydrogen. It's an energy level 1, period 1. So 1, this is our S sublevel. So S, we mark out hydrogen, we mark out number 2, which is helium. That's 1s2. When we hit lithium, it's in period 2 of, again, the S sublevel. So 2s, we cross out lithium, we cross out beryllium, we cross out 2 elements, that's 2s2. So notice the coefficient 1, that coefficient 2, those coefficients are the energy levels, which are the periods on the periodic table. The letters S and P, D, and F, those are our sublevels. And up here, our superscripts are the electrons. So if I add those two superscripts, 2 plus 2, I get 4. And I needed 4 electrons with beryllium. Okay? So let's try another one. Remember, you can pause the video and re-watch and practice as many times as you need to. This time, let's do phosphorus. So erase your periodic table. Remember, you should be trying this with your dry erase. Here's phosphorus. It has 15 as the atomic number. So 15 protons. Protons identify it. So 15 electrons, because protons equal electrons when they begin as neutral. So we have to cross out every single element in chronological order on our way to phosphorus. We begin with atomic number 1 every time, hydrogen. Energy level 1. It's in this S sublevel sticking up. So 1s, hydrogen's 1, helium is 2. 1s2. Then we get down here to lithium. It's an energy level 2. It's here in the S sublevel. So 2s. We mark out lithium, beryllium, 2s2. Then we get to come all the way over here to boron. We're still in energy level 2. But now, with these sticking up, we've entered the P sublevel. So we have 2P. And I've got to go from boron to neon. 1, 2, 3, 4, 5, 6, 2p6. Still not to phosphorus, so we keep going. We hit sodium in period 3. So it's energy level 3. We're in the S sublevel. So 3s. We cross out sodium, magnesium, 3s2. We've got to come all the way over here to aluminum. We're still in the 3rd period. We've entered the P sublevel, 3p. And we've got to cross out aluminum, sulfur, and phosphorus. We X'd out 3 elements, so 3p3. The superscript is our electron number, so we do a quick check. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 3 is 15, and we needed 15 electrons. So remember, our superscripts are our electrons, which total the number of electrons in our atom. Okay, let's try another atom. Let's do vanadium. Vanadium. So let's erase our periodic tables and try again. Remember, you can pause the video at any time, rewind, watch again, practice again. We're dealing with vanadium. Okay, vanadium's right here, atomic number 23. So that means 23 protons, 23 electrons, because they all begin as neutral. So we have to cross out every element in chronological order on our way to vanadium. But notice vanadium is in the D sublevel. Where these first 2 sticking up, 1a, 2a, that's S. These 6 that stick up, excluding helium, is our P sublevel. Okay, so where vanadium is in the D sublevel. Remember, when we enter D, the energy level drops by 1. So if we notice, the D sublevel begins where I'm highlighting these elements. So that'll be important to remember when we get to that sublevel. All right, so we begin here with hydrogen, as always, in the first energy level of the S sublevel. So 1s, we X out hydrogen, we X out helium, we X out 2, 1s2. We hit lithium, 2nd period, 2nd energy level. It's in the S sublevel. So 2s, we X out lithium, beryllium, it's 2s2. Then we come all the way over here to boron. We're still in period 2, but we've entered this P sublevel. So 2p. We cross out every element in that sublevel, which is 6. 1, 2, 3, 4, 5, 6. So 2p6. We're still not to vanadium, so we keep going. We hit sodium in period 3. Energy level 3. We're still in this S sublevel, so 3s. And we mark out sodium and magnesium. So 3s2. Then we got to come all the way over here to aluminum, which is in the P sublevel. So the energy level doesn't change. It's still 3. So 3p. And we've got to mark out all 6 of these elements. So 3p6. We're almost to vanadium, but not quite. So we keep going. We hit potassium in period 4. So now we're in the 4th energy level. Okay, so notice I ran out of room on my other line. I just continue going on the next line. I'm in the S sublevel. So when I mark through potassium and calcium, that completes 4s2. But now I enter scandium. Notice when I hit scandium, I'm in this D sublevel, where the energy level drops by 1. So when I entered D, I notice here my main period was 4. So if it drops by 1, now it's going to go from 4s to 3d. So now I'm in 3d, and I've got to mark out scandium, titanium, and vanadium. I marked out 3 elements, so 3d3. Then we do a quick check of our electrons, and what that means we add our superscripts. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 3 is 23, and we needed 23 electrons. So the thing to remember on our way to vanadium is when we entered here, period 4, we went from 4s, and then when we entered scandium, we entered the D sublevel where the energy level drops by 1, so we went from 4s to 3d. The energy level went from 4 to 3, it dropped by 1. Okay? So let's try another one. This time, let's do the element 10. Okay, so 10 is Sn. It comes from the Latin word stannum. So we're going to work with 10. So find 10 on your periodic table. Make sure you've cleared it out, erased it. You can pause the video when you need to. So we've got to go through 50 electrons. So here we're going to have 1s1, 2, 2s2, 2, we've entered the P sublevel, so 2p, 1, 2, 3, 4, 5, 6, 2p6. Third energy level, S sublevel, 1, 2, 3s2. We come all the way over to aluminum, so we're still third period. We've entered the P sublevel, so 3p, 1, 2, 3, 4, 5, 6, 3p6. We hit potassium, which is the fourth period, fourth energy level. We're entering the S sublevel, 1, 2, so 4s2. Now notice, as soon as we hit scandium, we've entered the D sublevel where the energy level drops by 1. So if here we were in 4s, then when we hit scandium, now we're going to be in 3d. So we've gone from 4s to 3d. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3d10. As soon as we hit gallium, notice we've entered the P sublevel. So the energy level goes back to what it was. So if you come back over and look, our energy level was period 4. So we come back to 4p. So if we notice here, when we went from 3d, we went back up to 4p. It went from 4s to 3d to 4b. We've got to mark out all these elements, 1, 2, 3, 4, 5, 6, 4p6. Still not to 10, but almost. So we keep going. We hit rubidium, which is period 5. So energy level 5, and we're hitting that S sublevel, so 5s. And I'm marking out rubidium and strontium, so that's 5s2. Now notice, as soon as I hit atomic number 39 here, I've entered the D sublevel, where the energy level drops by 1. So I've gone here from 5s, and I've gone now to 4d, because the energy level drops by 1. So I've gone from 5s to 4d. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4d10. As soon as I hit indium, I'm going to the P sublevel where the energy level goes back to what it was. It was 5, so we're going back to 5p. Okay, so notice we went from 5s. Okay, so if we come back up and look, we went from 5s to 1, 2, to 4d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, back to 5p. And we're on our way to element 10, which is right here, 1, 2, so 5p2. And again, we do a quick check of our electrons. 2 plus 2 is 4, 10, 12, 18, 20, 30, 36, 38, 48, 50. And we needed 50 electrons. So again, When we enter here, this D sublevel, the energy level drops by 1. So what that means is if we have gone from 4s2 and hit scandium, now we're at 3d. If we've gone through all of 3d, then when we hit gallium, we're back in this P sublevel and the energy level goes back to what it was. If the energy level was period 4, then we go back to 4. So we're going from 4s to 3d to 4p. Okay, same thing with the next row. We hit period 5, we have to go through 5s, and as soon as we hit atomic number 39, we've entered that D sublevel where the energy level drops by 1. So we've gone from 5s now to 4d. If we go all the way through D, then as soon as I hit indium, we're back in the P sublevel where the energy level pops back up to what it was. We started in period 5, then it goes back to 5p. So we went from 5s, 4d, 5p. Okay. So we'll do one last one, and this time we will do promethium. Promethium, atomic number 61. So 61 protons, 61 electrons. Again, you can pause, stop, rewatch anytime you need to. So we're coming to promethium here. So we have to start all the way back up at hydrogen. Now remember, it's helpful to always mark where D and where F begin so that you'll know when you need to take the energy level and drop it by 1 when you hit D, and when you enter F, that the energy level drops by 2. So that's really important. So I like to always make sure I know where my D sublevel starts and ends. So I'm marking that, and where my F sublevel starts and ends. Okay. So on our way to promethium down there at 61, we're going to have here hydrogen, which would be 1s1. Helium would be 1s2. So we have 1s2. So we hit lithium, period 2, s1, 2. So 2s2. We come over to boron. We're still in period 2, but now we've entered this P sublevel, the P block. So 2p. And we got to go through all of these elements. So we have 2p6. Third period, third energy level. We've entered the S sublevel, S1, 2, 3s2. We hit aluminum. So we're still in the third period, but now we've entered this P sublevel, and we've got to cross all the way through aluminum to argon, 6 elements, 3p6. Okay, now we've hit the fourth energy level. So period 4, fourth energy level. Potassium and calcium completed our S sublevel, 4s2. Now we've hit scandium, which I've marked with the highlighter, telling me I'm in the D sublevel where the energy level drops by 1. So I've gone here from 4s, and I've now hit 3d because the energy level dropped by 1. And I've got to fill all these elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, I highlighted where D stops at zinc. So I've got 3d10 filled, which means as soon as I hit gallium at atomic number 31, I've gone back to my P sublevel. So the energy level goes back up to what it originally was. It was originally 4. So I've gone back to 4p. 4p. So notice here we went from 4s to 3d to 4p. We've got to cross through all 6 of these elements. So 4p6. When we hit rubidium here, we're in period 5. So the 5th energy level of the S sublevel, 1, 2. So notice this was 5s. We hit atomic number 39 in the D sublevel where the energy level drops by 1. So we're going to go from 5s to 4d. Okay. We filled the S, so we're going from 5s to 4d. We got to go through all those elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As soon as we hit indium, notice we entered the P sublevel, so the energy level goes back to what it was. It was period 5, so we went back to 5p. So again, we went from 5s, 4d, to 5p. 1, 2, 3, 4, 5, 6. So we have 5p6. All right, so now we're entering that 6th period where we have to be careful. So we have period 6, energy level 6, cesium and barium, complete that S sublevel, 6s2. And now be very careful because your atomic number, as soon as you crossed out barium, was 56, prompting you to come down to 57. When we hit lanthanum at 57, we're in the F sublevel where the energy level dropped by 2. So if we're in the 6th period and the energy level drops by 2, now we're in 4F. So we've gone from 6S to 4F. 56 to 57. Our atomic number told us to do that. So we went from 6s2 to 4f, and we crossed out the elements on our way to promethium. 1, 2, 3, 4, 5. So we have 4f5. Okay, so again, as soon as we crossed out cesium and barium, we were finishing 6s2. The atomic number 56 told us to drop down to 57. Now we're in the F sublevel. The energy level drops by 2. If we were in 6, then now we're in 4. 6 minus 2 is 4. 4F. 1, 2, 3, 4, 5. Because we were trying to get to promethium. That's how we went from 6s2 to 4f5 at the end of that electron configuration for promethium. We do a quick check of the electrons. 2 and 2 is 4, 10, 12, 18, 20, 30, 36, 38, 48, 54, 56, 61. And we were trying to get 61 electrons. Okay. So you cross out every element chronologically in order to get to the element that you're dealing with. So we want to remember that when we do an electron configuration like this, the coefficient here is our energy level, which corresponds to the period, the horizontal row, left to right, on the periodic table. This letter S, or P, or D, or F, that's our sublevel. Okay, and that sublevel corresponds to certain groups and families on the periodic table. And this superscript, okay, super because it's above, okay, that superscript is the number of electrons in the sublevel, okay, not the orbital in the sublevel. Yes, orbitals make up sublevels, but notice the superscript 2 comes after the letter S. S is the sublevel. So this 2 superscript tells me 2 electrons in the S sublevel, okay? And so as we go through our periodic table, and we're crossing out all these elements in order to find the one we want, we're following off-bow order, remember. Off-bow order is what tells us that electrons are filling the lowest energy levels first, okay? So remember that electrons ultimately live in orbitals, but they have to fill the lowest energy levels, sublevels, and orbitals that are closest to the nucleus first in order to be the most stable. Okay, and remember, that's what we call off-bow order. Off-bow order. So when we're crossing out those elements on the periodic table to do the electron configuration, you're finding the electron's address, essentially. You're doing off-bow order. You're talking about how electrons have to fill the lowest energy levels, sublevels, and orbitals first, because they're the closest to the nucleus. And the reason they want to fill the ones that are closest to the nucleus first is because those are the most stable. And everything's always about stability. Atoms want to be stable, and they're going to do whatever they can to make themselves stable. So off-bow order is telling us which energy levels, sublevels, and orbitals are filling first, because they're going to be the closest to the nucleus in order to maximize their stability. That is what we are following as we go through the periodic table and follow all of these 1s2s, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, 7p6. That's our off-belt work. The periodic table is off-belt work. All right, so if you are still having issues or trouble and you need help with electron configurations, please make sure that you continue to practice and come and see me. Thanks.